Welcome guys to episode 13, electrical part 2. In this episode we're going to go through the fit off of all the electrical and the battery system and everything like that. So just remember guys that I'm in Australia and the wiring rules AS3000 and AS3001 are for Australia and New Zealand only. So if you're watching and you're from another country, your wiring rules are most likely going to be different. I'm going to give as much information as I can in this episode, but I will reserve certain things about the battery and everything, like really in-depth information for season 2, where I go into each individual part of the van and actually how it works. So this video will be more like an overview of the electrical, not super in-depth information. Okay, so I'm gonna explain to you exactly how this reverse camera works. What I had to do was tap into my reverse lights just there and grab a positive and a negative 12 volt supply, so that when I put my van in reverse, it sends voltage to the camera and gives it power and powers it up, and then sends the video back all the way to the head unit, as well as a 12 volt positive. So it tells the head unit to switch into reverse mode and bring up the reverse camera on the head unit. So that's what's happening. So what I actually did, saw me in electrical part 1, and I ran those 2 data cables from the back door to the front head unit. What I actually ended up doing was cutting into one of them. I cut into one of them here and ran another cable down to the back light. So this is where I tapped into my 12 volt for my reverse lights. So you can see black and white, that's just my 12 volt. That comes back to here, sends that back up to here, and gets joined into the red and the black of my reverse camera, which goes to that red and sends power to the camera. Then that sends video back through this yellow one, and then that joins to here. So that joins to here, the yellow and the black of the video join to those 2 cables that go all the way back to the head unit. Alright guys, so I'm going to run you through the back and the wiring behind of what's going on here. So first off, we'll start with the easy things. This is just the GPS plug-in point. This is the digital radio point. Alright, so this harness here, first off I'll just tell you that I had to hook in to accessory power. So that means that when you turn the key, this gives a 12 volt signal, but when you turn the key off, it's dead. So I had to hook in from an existing accessory feed there, and I soldered that to the red wire in the harness which says accessory. So that basically turns the unit on and gives it power when you turn the key. Another thing that I did on this harness is wire into the reverse pink cable, and that is from the back. That's our number 2 cable, and that comes from the back with the brown white, and that basically sends a 12 volt signal down to the reverse, which lets the monitor know that you're in reverse, display the reverse camera on the screen. The other 2 ones are what you saw before, which is the blue white and the orange white, and that's basically just carrying the video feed. So it goes down the yellow and the black, down the yellow and black to where that plugs in to cam, which is where that is. All the other ones are basically just for like other speakers and stuff, but all I needed was the cam input. So this harness plugs into the CAN bus, the standard CAN bus of the vehicle. So that's getting like your 12 volt, that's got your speakers and stuff in it. And also what's hanging off this harness is this thing here, I don't know what to call it, but basically it has dip switches, and you set it to what Mercedes model you have. So I set mine to Sprinter. I tried setting it to another thing, and it just makes it so that the monitor, this head unit, does not work if you do not set it to a Sprinter. So that's just like some security thing. So basically that's it. That's the wiring. I will include a wiring diagram in the blog post for this episode, so go to my website and check that out to get a much clearer description of what's going on.
Check out travelwithjaz.com. It's where where new and independent music makers from all over the country upload their latest creations. And it's where music lovers like you can discover your new favourite artists. Which acts from on Earth are going to make the hottest 100 countdown this year? Listen in from 12 Australian Eastern Daylight Time tomorrow to find out.
This is the external ceiling shroud for the exhaust fan in the bathroom. Now I had to modify it and cut it down slimmer because it has to fit under a solar panel. So I re-drilled out the pop rivets and then I tested what size would fit underneath the solar panels. Then I marked it out, cut it smaller, and then I pop riveted back together and then put it underneath the panel. I measured it a lot of times just to triple check exactly where I can drill the hole so that this lines up perfectly inside in the shower. And once I drilled through the roof, the pilot hole popped out the bottom in the ceiling, and then I used that as a marker to know where to drill from the bottom. And I attached a small little 100mm flue just so that no moisture would get inside the cavity of the ceiling. Once everything was in place, I used Sikaflex 221 to seal around the sides of the vent and then also to mount the vent to the roof, and it fits underneath the panels perfectly. Next I started prepping my AC switchboard and solar isolator enclosure, and then I just mounted this to a bit of melamine chipboard.
Everything I was holding on to so tightly, and it hit me that I don't have an intellectual reason. I don't need one.
So I fed all the cables in and got the board into place, and you can see I used pocket hole screws to screw them into the sides. In Australia, by law, you're not allowed to store things in front of a switchboard in a cabinet, so that's why I had to put the panel in so that to make the space too small to store things in front of the switchboards. I stripped all the cables and twisted the earths together and put them under one earth screw. And I used Hager 16 amp double pole C-curve type A breakers. These are pretty much the same ones as you'd put in your house. These cables that I'm terminating are the line side fed from the 15 amp inlet. And these cables that I'm terminating now are being fed from the load side of the inverter. These cables are the load side of that breaker, and they're feeding the line side, the input of the inverter. So what I'm twisting now is all my final sub-circuits going out to my GPO power points. Next, I installed the power points inside the safe. I cut out all the holes for the Enerdrive battery monitors and also for the 12 volt DC switchboard. I measured and installed a divider for the battery area. Next, I placed and mounted the board that has all the inverter, the charge controllers on it. After this, I carefully placed the 200 amp hour lithium ion battery. Now these are the cables that Enerdrive supply you with to fit off the battery. Some of the ends come pre-lugged, but I had to make a cut in where the isolator is and use and crimp their lugs that are supplied with the kit myself. I hired a hydraulic crimper from the wholesaler and used this to crimp the lugs. After I crimped the lugs, I put heat shrink on and used my gas torch to heat it on. The shunt has a system side and a battery side, so I came off the negative side of the system and put it on the system side of the shunt and wired up the battery side to the battery side of the shunt. Next I mounted the battery balancing module and screwed this into the dedicated battery connection. And then I fit off the two orange positive and negative cables to the starter battery of the van. I then installed another double pole RCBO to protect the outgoing side of the inverter all the way up to the line side of the breaker. I had to run two Ethernet cables from up in the switchboard in the cupboard down to the bottom to plug into the battery shunt and the inverter. And then I run a 6mm earth from the chassis connection and ran that to the inverter. My 15 amp 240 volt inlet wasn't long enough, so I had to do a solder join inside the little enclosure and hide it in there. Next I put a lug on the 6mm earth to the inverter and then fitted off the input and the output sides of the Combi inverter. Once I finished that, I finished wiring up the battery management system. Now I used a riv nut to bolt the earths to the van chassis. Next I terminated my 80 watt and 500 watt solar arrays into the isolators. I cut holes and terminated my hot water and tank gauges. Next I cut out the hole for the 5-gang switch plate for all my lights and terminated them off. I just soldered all the neutrals together and then wired up the switches and feeds separately. Next I drilled a hole for another 240 volt power point outlet and the switch. I covered the back with mounting blocks and fed the Coro into them, and then I covered blank plates on top of the mounting blocks. Next, I use a hole saw to cut out the lights. I then soldered all the connections to the LED lights. Next, I drilled the holes in the back plates of the door for the down external lights. I used Sikaflex 221 to secure the angles on the side metal there, and then I screwed the other three to the ceiling with screws. I used these angles as brackets to screw the timber to create the bulkhead. And I protected the wires by screwing over these wall plugs over the screws so that wires could not be damaged by the pointy screws. Next, I mounted and wired up the Caframo Sirocco 2 fan.
Alright guys, so that's it. Finished fitting off and showing you how everything was done electrically. Now it's time to run through. So first I'm at the front of the van, and as you've seen there's a light switch just here. So that controls all the lights in the van. So I've got this one light here at the entry on a single switch, and then I've got these 6 lights there on another switch. Then I've got the 2 back door down lights on another switch. Then I've got the shower light and the exhaust fan on separate switches, but I'm thinking about putting them on the same switch as you pretty much always use them together anyway. So with this exhaust fan, as you saw, the shroud vent underneath the solar panel, I had to modify that to fit underneath the panel. There was no other room for it. I haven't had any problems with leaking through. It's sealed. The shroud still works great. So yeah, there's no problems with that light at all in terms of water getting in. Now because this is an extraction fan, when you're having a shower, you're obviously going to have that door sealed closed, and that's it's a watertight seal, but it's not airtight. But the extraction fan definitely does work better when the door's open, but it still definitely works fine when it's closed, just not as good. So there's the bulkhead that I put up to cover all those yucky wires. I think it turned out really good and blends in really well with the other timber of the roof and the walls. And I've put some hooks up here to hang some clothes, towels, tea towels, and this little benchtop wiper. This is another architrave switch that controls the bench LED light there. So that's really handy when I get up in the night. It's really easy to access, and it's easy because it's above the kitchen, so you know, it's a pretty ideal spot for it. So in this van I've got 3 internal double power points, and I've got 1 external on the outside. All the power points in this van are double pole, which means it doesn't just switch the active,
it also switches the active and the neutral, and that's required by AS 3001 that all AC low voltage equipment needs to be double pole in a caravan or a relocatable premises. So I've got one in the safe, I've got one power point here on the kitchen, and I've also got one over here. I've also got 12 volt dual USB outlets. There's one there, there's also one here, and there's one just behind that board on the back door. So this switch actually isn't wired up yet. I'm gonna have some warm white fairy lights along here just to be a bit more dim, really dim lights over the bed at night time so it doesn't, you know, strain your eyes when you want to go to sleep. Now, as you know, I've got one max air fan there and one here, but I found that it was just a bit too hot at night time when you're sleeping. On a hot night, you just need direct airflow on you. So shout outs to my mate Charles, who suggested this Caframo Sirocco #2 fan, and it works really good. It's called a 360 fan because it can swivel all the way around and go all the way up and down as well, like that. And it has 3 speeds. So that's off, you just click this button. That's 1, 2, 3. It also has a timer, so you can set it, click this once, the LED comes on, that's 3 hours, 6 hours, 9 hours and 12 hours. So, you know, if you want to set it for 3 hours, you just click it once and in 3 hours it'll turn off. It's an ingenious fan. It blows a lot of airflow for the size of it, and also it draws next to no power. So it's a 12 volt fan, and I think on the highest setting it draws like 0.35 of an amp, so it's amazingly economical as well. So just quickly about the switches, that's only switching 12 volt, so they don't need to be double pole, they're just single pole switches. But anything, 240 has to be double pole in a relocatable premises in Australia. Okay, so we're underneath my bed now, and this is basically the heart of the van. This is all the electrics here. So this is a 200 amp hour lithium iron phosphate battery. It's slimline, as you can see, it doesn't really take up very much room at all, and it weighs probably 35 kilos. So all these products are made by Enerdrive, who specialize in battery technology, and I'll run you through a little bit about what each component is doing. Just coming down here, this little red switch here is the isolator, so that isolates the battery from the system. So you would turn that off if you wanted to store the battery for a long time and you were not using your camper van, or for whatever reason you wanted to isolate it manually. So this is the battery balancing component here, and what this does is it looks at each cell, because there's different cells inside the battery, and it looks at what voltage and everything they are. It'll transfer the energy from a higher cell and balance that across all the cells. Now this is the economical way to do it, because it doesn't just waste the energy to get rid of the energy and make it even to the other cells. It actually transfers the energy from that cell and dilutes it across all the other cells to use that energy. And this prolongs the life of the battery and is quite economical. So the next thing is the battery shunt. So this basically feeds from the negative of your battery and goes through this thing called a shunt. So a shunt is basically monitoring the current, the voltage and everything of what's going on in your battery. This then uses that information, and you can see little information wires going to the next thing, which is a battery management system. So this thing is the heart of protection for your battery. This is having, you can see all the little things feeding different parts of the battery management system, and that is feeding it with information, telling it exactly what state the battery is in, and if anything's wrong, it'll flick this little relay here, and that will disconnect the battery from anything or any loads like that, so that you can't do further damage to the battery. So basically that's purely there for protection of your battery. This next component is a Tristar 45 amp Mppt solar charge controller. So this one module is what the 500 watts of solar is feeding, just this alone. So that's pretty much all it does. It tracks what your solar is doing, it will up the voltage or up the current for whatever it needs to get the most efficient output to charge your batteries as best as possible. The next device is a 40 amp Mppt also, but it's slightly different. I've got two different inputs feeding this Mppt. So I've got my 80 watts of solar, which is the small panels feeding the solar input on this, and you can see the orange cables down there are coming from the battery, the starter battery of the van. So what this does is it will detect the best possible input and choose that to then feed back to the battery and charge it. This is being fed from the 80 watt solar array on the roof right now because the van engine isn't started, but I'll go start the engine and this will click over and select the alternator as its primary source of input because it's a much higher current input. So the van started and I'll just give you a little, I'll show you what's happening. So right now the solar is pumping about 19 amps into the battery, and this thing in a minute will click over. So it's still connected to the 80 watt solar array and it will automatically connect to the van in a couple of seconds. There you go, you just heard it click. Now it's switched over to the van and you can see that the current is raising. It's pumping in 12 amps, 14 amps, 16, and it will probably raise up to about 30 amps. There you go, so that's topped out at 30 amps. It's pumping back into the battery and that's being fed from the alternator. So I'll just come up here and now you can see that's pumping in 45 amps because it's pumping in 30 amps from the alternator of the van and the rest of it's just from the 500 watt solar array from this Tristar solar charge controller. So if I was to turn the engine off now, I'll show you when it disconnects. So the engine's off, it's still going to be connected to the battery for about another 15 seconds and then it automatically disconnects. Still pulling from the battery, the relay is going to detect that the van's no longer started and it will click back over to 80 watts to protect your battery from running flat. There you go, it's detected that the engine's no longer running and it's switched back to the 80 watt solar. And if we come up here, that's dropped down, so that's feeding back again from the 500 watts and the 80 watt solar array. So that just makes it so that, you know, it's automatic. You don't have to think about switching like a manual switch to charge from your alternator or not. It's automatic and it protects your battery from running flat when you're not running your engine. Okay, so next we're going on to the Pro Combi Inverter. So it's a 1600 watt, 60 amp, pure sine wave inverter. So because I'm going to be pretty much 100% off the grid, I'll explain to you how it works off the grid first. So right now, and 99 to 100% of the time when I'm in this van, it will be an inverter. So it's getting fed from this battery, the 12 volt battery, and it feeds this inverter here. So it's changing 12 volt DC, and on the output side of this, it turns it into 240 volt AC to run all my PowerPoints, appliances, like toasters, blenders, and all that stuff in the van. Now it's a pure sine wave inverter, so that means that it's basically exactly like when you're plugged into mains. It's a sine wave, it's not a modified. So you want a pure sine wave if you're running things like laptop chargers and all that stuff. They prefer pure sine wave as opposed to modified sine wave, which is more of a square pattern. Now this inverter has an input side and an output side. So right now it's basically just utilizing the output because it's getting fed from the 12 volt battery and then it's outputting 240 volt AC. So if we come into the switchboard cabinet above here, I'll explain the AC side first. So first I've got where the inverter's located, obviously under the bed, and I'll explain to you what these circuit breakers are doing. So first off, this circuit breaker on the left, I've labelled it main switch grid supply. So basically this will rarely and seldom ever get used because this is fed from the incoming 15 amp plug on the outside. So if I plug into mains, it feeds the line side of this circuit breaker, and then the load side comes all the way down. And as I said before, it feeds the incoming side of this inverter. So when you're plugged into mains, two things happen. It just diverts all your PowerPoint loads that you're running in your van straight to mains through in a little switch in here. And it also begins charging your battery if your battery needs charge. Whether or not you're in off-grid mode, inverter mode, or in mains mode, they both come out through the same output, and they go through this corro here, which feeds this circuit breaker here. It's an RCD. It's the same style as the ones up the top. Now, all this breaker does is just protects the run of cable from there to there. It might be a bit overkill, but I did it anyway. So that comes out the back and then goes up the wall. And then it feeds the line side of this breaker here. So this is called main switch inverter supply. So this is fed from the output of the combi inverter down the bottom. And then on the output side of that, it will feed all your power points inside the van. So 99 or 100% of the time, I'm probably never really going to use this because I'm going to be off the grid all the time. So if I click the test button, nothing's going to happen because I'm not plugged into mains. But right now I'm off the grid, and if I click the test button there, that'll trip. So that proves that everything's working. And if I click this one down here, that'll trip as well. So that breaker and that breaker are on the output side of the inverter. And I'll put a sticker here that says warning multiple supplies, isolate all supplies before working on this switchboard. Because if I was plugged into mains, or a future owner of this van was plugged into mains and they wanted to do some electrical work, say on the power points, and they thought, okay, I'll isolate this switch here. All the power points are isolated because they think, oh yep, I've isolated the main switch grid supply. Technically it wouldn't be isolated because this inverter would switch into off-grid inverter mode, and it would now be getting a feed from this battery, and it would still be feeding and outputting 240 volts. So if you wanted to work safely, you'd have to isolate both supplies. And now you've isolated both supplies to the power points. So next I have my two solar array isolators. So if we come over here, if I isolate the 500 watts, yeah, that's pretty much feeding the whole van right now. If I put that back on, it's pumping around about 19 amps. The 80 watts, isolate that. That's only doing a couple of amps. So they just isolate your two arrays on the roof. Next we have my DC fuse board. Now it's pretty messy, but I did the best I could to do it all neatly with this size fuse board. So I've labeled everything here. You can tell what everything is. And underneath this clip, it's literally just fuses. So that's running everything from hot water system, pump, the light feed, the fridge and the cooktop, the bed fan, both the max air fans, and all the 12 volt dual USB outlets. That's what that's running. So this is the display for the combi inverter down the bottom, and this basically just mirrors whatever that's reading out, and it gives you a multitude of things you can scroll through. So the battery voltage, current, temperature, and it gives you a reading of the volts in. So if I am plugged into mains, it'll tell me all the incoming statistics, and it also gives you the AC out, so all the statistics on the outcoming side of the inverter. And below that we have the ePro monitor. So this is fed from this one here, which directly reads from the battery. It's fed from the shunt. You can see it plugged in there, and that just plugs into the back of the ePro monitor. So this is purely monitoring your battery. and as you can see, I'm at 59% charge right now, and it's just breaking even. My solar, where I'm parked right now under the trees, is just breaking even, and it's pumping in some current there. You can see that it's putting in about 2 amps or so. It's fluctuating, and that's charging the battery. You can see that the little semicircle is moving in this direction, which means it's charging. If it goes in that direction, the opposite way, it means it's discharging, and there'd be a little negative symbol just in front of that there. So just to show you that, I'll isolate the breakers to isolate the solar, and you can see now that's a negative symbol. I'm using 5.5 amps, and now it's going in the opposite direction, that little semicircle. See that? Now that's just reading amps, like real time, but you can go through, that's how many watts that's going into the system. That's how many amp hours I've used. It's got the voltage of the battery. So I've just isolated these again, just to show you this one. It gives you a estimate of how long your battery is going to last if you were to continue using this amount of power. So that says 31 hours, and it adjusts, yep, because I just isolated it. It's going to adjust down to 26 hours there. So if I was to keep pulling that amount of power, it would last roughly 22 hours without charging at all. So I'll flick them back on. So I pretty much just look at this one exclusively. I might look at this every now and then just to see what's happening on the AC side of things, but really I just mainly look at this this battery monitor here. Alright guys, so behind me, I'm just going to do a quick little test. I've got my 800 watt toaster here, and I just want to show you the difference between AC current and DC current. So the battery is obviously 12 volt DC current feeding the inverter, but on the output side of the inverter, it's 240 volt AC. So I just want to show you the difference between the current draw on the input 12 volt side and the output 240 volt side in terms of current on the inverter. So the toaster's off right now, and there is no current being drawn on the AC side, and at the moment I'm drawing 8.66 amps on the battery. Alright, so I'll turn the toaster on. That's heating up now, you can see it's on. So I've come back and it's drawing 3.4 amps AC, but on the DC side it's drawing about 80 amps. You can see that. So you can see that on the AC side it was drawing only about 3.5 amps, so not very much at all. But on the DC side it was drawing about 80 amps. So just want to let you guys know that the difference between 12 volt amps and 240 volt amps, the higher the voltage, the less the amps. So that's why 12 volt draws such high amperage. So it would run a 200 amp hour battery flat pretty quick if you just left this on for like an hour or so. But you only use a toaster for a couple of minutes or a blender for a couple of minutes at a time, so it really doesn't matter. Pretty much everything in here is an Enerdrive product, and they specialize in batteries, inverters, and off-grid equipment. Solar panels, my solar panels are Enerdrive panels. So, but you cannot purchase directly from Enerdrive. They only deal with dedicated retail outlets. So I actually purchased all this through Battery World in Enoggera. They were really good, really helpful. So I bought it through Battery World, and then they have to purchase it through Enerdrive. So you cannot go through Enerdrive directly. Everything here on the back part here with the inverter and the solar charge controllers and these links and everything, that all comes on this board, and Enerdrive made all that up. So that's really easy. It just came all on one board, and all I had to do was wire it up. So that was really handy. So far I'm really happy with this product. I'm loving the battery, it's working great. I'm really glad I chose lithium ion over anything else. It's really slimline and it's got so many benefits. The only thing is it's more expensive, but for what I want to be 100% off the grid, it's definitely worth it, I think, in this case, and it will pay itself off in the long run for sure. Now there's probably a few things that I've left out and some questions that I'll have to answer in comments or another video. But that's just the rundown on the system. I do want to make a dedicated video in season 2 as to why I chose lithium ion over AGM batteries. There's definitely a few reasons. Alright guys, I hope this video has been helpful, and I know there's still a lot more to cover in terms of like why I picked lithium over AGM and how my system works on the road and everything like that, which will all be in season 2. So as you know, I've just started living in my van, so it's a really good time to test everything out, give it a stress test so I know the limits of everything. So over the next few weeks or months, I'll be recording season 2. That will be all about like how things actually work. So I will give you an in-depth rundown on the battery, how long it lasts, like why I picked the size battery, how much current everything draws, like all those things in terms of electrical. And also like the shower and everything else, plumbing, kitchen, I'll do it all in season 2. I will include a bit more information than this video in the blog post that I write for this episode. So once I write that, just go down to the bio below, the description, and click on the link for episode 13 blog post. And once I've written that, it'll have all the information there for you to look at. Stay tuned for the next episode because that's going to be about the floor and the bed. So that's pretty much the last episode I have to do until I do the final van tour for you all to see. If you're interested in my van journeys around Australia, again, go follow me on social media and share this video if it's given you value, and share it to your family or friends. Give it a like, subscribe, come along for the journey, and I hope to keep inspiring you guys. So thank you once again for watching. Stay tuned for the next episode, and I'll see you then.